Okay, so now let me do one thing, just a second. Okay, now you will tell me, let me draw the triangle as well. That is the O Q N triangle. Okay, from this you will tell me what is the vector addition law. Okay, let me show you the direction. This is the direction of OQ vector. Okay, this is the direction of ON vector, and let me check the direction. Okay, the Qn vector's direction is from left to right. Okay, is the picture clear to you?
Yes.
Tell me.
Yes.
Okay.
Yes.
Yes, I mean, go ahead and tell me, like what will be the addition vector from this triangle?
Oh, OQ
Yes.
OQ plus QN is equal to ON.
Okay, good, very good. Equals to ON. Okay. All right, so we have worked with this triangle as well. And another one is left. Another one is okay. We don't have to work with another one. Okay. So now let's see what they have done. What they've done is ON vector equals to OQ vector plus QN vector, and OP vector is equals to ON vector plus NP vector. So now the value of ON vector in the first equation will be replaced. Okay, it is replaced here. Okay, so then we get OQ vector plus QN vector plus NP vector. Okay,
Okay.
all right. Is it clear? Like we have
Yes.
just replaced it in case of like the equation. Okay, let me remove all the drawings. Now we have previously mentioned that OQ vector is the like xi vector y because it's along the x-axis, and along the x-axis unit vector will be I hat, and qn vector is mentioned to be yj hat because it's a vector along the y-axis, and np vector is zk hat because it's a vector along the z-axis. Okay, and obviously you understand that the coordinates can be seen from here, that they are like, can I say, from y distance from the O point, from like x distance from the O point, and z distance from the O point. Okay, now you might as well ask, Bhaiya, if qn is equals to y, then it is wrong because it should be something like this, should be y, right? This is what you are thinking, isn't it?
Yes.
Okay. But the thing is, see, it is a three-dimensional space. As you can see, it feels like it's like not in shape, right? The thing is not in shape. That is why it's sort of confusing. Okay, but actually the thing is like what you are wanting. The thing is actually like that. Okay, there is no problem in that. The thing is actually like that. Okay, understand my point?
Yes.
Okay. All right. So now OP vector was R vector. So R vector will equal to uh, OQ vector, which is xi hat, and then Qn vector, which is yj hat, and NP vector, which is zk hat. Okay. All right. Okay. So now we have already got the like resolution of a vector in a three-dimensional space. Okay, or three-dimensional coordinate system. Okay. So now here's an important thing. Whenever we are like working with unit vectors, the thing is, um, when you will like calculate the magnitude or the modulus of R vector, it will be something like square root of x squared plus y squared plus z squared. Okay, because this I, what did I say in case of I? I meant I hat is the unit vector. That means its value is, or magnitude is 1. All right. Its magnitude is 1. Understand my point? So I
Yes.
squared would be also equals to 1. Okay. So this is the basic thing, but also let's see the proof. Well, you will not need the proof, not this one or not anyone. Okay. Oh, sorry about that. Okay. So where was I? 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 Okay. So OP square equals to ON squared plus NP squared. This OP squared is equals to ON plus NP because this is a right angle triangle. Okay, and OP is the hypotenuse. Obviously, you won't be understanding it from the image. Okay, but for the time being, let us consider that. And ON squared equals to OQ squared plus QN squared. Okay. Now, from that, they have got OP squared equals to OQ squared plus QN squared plus NP squared. Okay, like in case of like hanging a stick in a rectangular, what is it, three-dimensional object. Remember that?
Yes.
So in that way, they've got this. So r squared equals to x squared plus y squared plus z squared. And if you take the square root of that, you will get the modulus value. Now, these are mostly the properties or characteristics of mathematics, which we will like very less in amount we will need in physics. But let's see that. So the unit vector along or parallel to r vector is r hat. Okay, because what did I say? In case of getting a unit vector, you have to divide that vector by its modulus value or absolute value or magnitude, whatever you want to say. Say, if I have a vector as p vector equals to 2i hat plus 3j hat plus 5k hat, then the unit vector along p vector will be, write it down, unit vector along p vector, it will be p vector upon the magnitude of p vector, which will be 2i hat plus 3j hat plus 5k hat upon, how can we get the magnitude if the like position vector is given in a three-dimensional space? It is just square rooting the addition of all the coefficients, right? That is square root of 2 squared plus 3 squared plus 5 squared. Tell me, do you understand this way? Very easy thing, not difficult to understand.
Yes.
Are we clear? Okay. All right.
Yes.
And this is the basic formula. You can write this down as well. You will need it.
Got it.
All right. Now, sorry, one second. Right. So, law of components of vector additions in that is, say for instance, whenever we are working with two vectors are given and we have to add them, and obviously, say for instance, a vector is represented as, sorry about that, a vector is represented as say 2i plus 3j plus 4k, and v vector is equals to 5i plus 3j plus 9k. Okay. So what will be a vector plus b vector equal to? So a vector plus b vector will be equal to, let us just write down the values. Okay, first of all. So it will be 2i hat plus 3j hat plus 4k hat plus, for b vector we have got 5i hat plus 3j hat plus 9k hat. So now in like general knowledge of algebraic like summations, we know that we have to add the coefficients of the similar terms. So similar terms here are i's. So that means 2 plus 5 times I hat plus 3 plus 3 times j hat and plus 4 plus 9 times k hat. That will equal to 7i plus 6j plus 13k. Okay, let me know when you're done.
I'm done.
This is the like basic rule for adding vectors. Okay, so nothing to worry about that. So you can write these things down, or you have it in the book as well. So if a vector, like these are like generalized terms: axi plus ayj plus azk, and bxi plus byj plus bx is the x coordinate of b vector, y coordinate of b vector, and ax is the x coordinate of a vector, and so on, so on. Okay. And addition of this vector is a vector plus b vector, and now I have obviously showed you in detail. Okay. Okay. Now, how can you get the modulus of the resultant vector? Okay, or the you have taken the addition vector, right? So how can you take the modulus of that? Okay, so very easy. So after like adding, you will take ax plus bx. That means the, what can I say, the coefficients of i's together, sorry, y x-axis together, or i's together, and coefficients of j's together, and coefficient of k's together, and then you will just square and add them and square root them. Say for instance, what was the answer for the previous question? Can you tell me?
Um,
Again, okay, okay, 7i plus 6j plus 13k, wasn't it? You write this down.
mm,
Okay, so now say we are willing to calculate the modulus value of this, or like magnitude. A vector plus b vector's modulus, this will be equal to square root of 7 squared plus 6 squared plus 13 squared. Okay, understand my point? So what you will do is firstly complete the operations in addition. You will firstly complete the operations in addition. Okay, then afterwards you will square root in like in the previous manner, whatever we did. Okay, all right.
all right.
So now tell me, what will be an unit vector uh, for a vector plus b vector? What will be a unit vector of a vector plus b vector? Understand my point?
You
For a
done.
vector plus b vector, tell me a unit vector. Let's see how much you have understood. An unit vector along a vector plus b vector. What should be the answer? Tell me.
Um, A vector plus B vector over A plus B. No.
What is a plus b? I didn't get you.
Um,
Okay, you are saying it to be a vector plus b vector over what?
plus B.
Okay, not a
But
plus b.
there,
You will say that it's the modulus of a vector plus b vector. Okay.
okay.
Modulus a vector plus b vector. Okay. All right. Now we have already calculated it. So what was that? A vector plus b vector was 7i plus 6j plus 13k over square root of 7 squared plus 6 squared plus 13 squared. Things are really easy, right? These are man, like piece of cake things. Very easy things, right? Are this difficult?
No.
Okay. But if you don't practice, then you will forget all this, okay? Because right now, I will keep on telling this to you because you need consistency, okay? These 2 years, you will need consistency, okay? Okay. All right. So can I erase them?
Yes.
Okay. In case of vector subtraction, the same thing. Okay, just like there is a minus sign in between them, you will do the subtraction as it is, and then you will calculate the modulus as it is. Okay. Do I need to show it to you?
No.
Okay. All right. So radius vector, we have already read about that. So it is xi hat plus yj hat plus zk hat, and modulus will be obviously you understand square root of the coefficients, right? That is x squared plus y squared plus z squared. Okay. Okay, now another thing is not all the time will you get things very difficult like in a three-dimensional coordinate system. You might sometimes get uh, some vectors which are in two-dimensional planes, okay, or two-dimensional coordinate systems. So in that case, all right, sorry about that. So in that case, what will happen is, see, um, you have the x coordinate and you have the y coordinate. That means you will have xi hat and yj hat. So you don't have to consider the z-axis and neither do you have to consider the k hat. Okay. Other than that, everything will remain the same. Okay. Say if in case of three-dimensional coordinate system, what did you have? You had xi hat plus yj hat plus zk hat, right? Just eliminate this zk hat from here and you will get the two-dimensional coordinate systems resolution, which is r vector equals to xi hat plus yj hat. Okay.
Yes.
Then, okay, very easy thing, very easy thing. And here you can also get the idea how the coordinate systems are right. Okay. Because in that particular image previously I showed you, it's difficult to understand. But as you can see from here, that it is correct. All right, and obviously modulus will be square root of x squared plus y squared, and unit vector will be same, xi hat plus yj hat over square root of x squared plus y squared. Okay. Mm. Well, let me just start. I won't be able to compute all of this. Okay. So in we have already understood about subtraction and addition of vectors. Now, what is the case in case of like multiplication or product? So there are two kinds of products of vector quantities. First one is scalar product or dot product. That is, the resultant would be a scalar component or a scalar thing, whatever you want to call it. Because component might be confusing. So the result would be a scalar. What is the term? Magnitude thing. Okay, it's a scalar magnitude. Okay. So a scalar quantity, right? Quantity would be better. Scalar quantity. What is the example to that? Example is work, because work equals to f vector dot s vector, and work is a scalar quantity. Work is a scalar quantity. And for vector or cross product, the result would be a vector quantity. Okay, result would be a, let me erase it. Result would be a vector quantity. Okay, would be a vector quantity. All right. And the example for this could be um, torque. Torque, torque equals to a vector cross r vector, and torque is a vector quantity. Torque is a vector quantity. Just show you the examples. We will obviously discuss it in detail. This is just like brief introduction. Okay. All right. That means the result we will get after like taking the cross product of force and radius vector, we will get a particular component or particular thing called torque. Okay. And this torque is a vector quantity. That means it will have both direction and value. Okay. And in case of work was equal to a vector dot is vector. So that means the dot product of force and the displacement vectors. Okay. And the resultant will have only values and no direction. That means work has only a value, no direction. Or the direction is not meaningful. Okay. So is it clear up until now?
Yes.
So we have read lots of things today. Okay. We have got understanding of three-dimensional space vectors, scalar products, vector products, and other things as well. Some like very basic topics as well. Okay. Inshallah, next day we will dive deep into scalar products, vector products, and vector products. Okay.
Inshallah.
Right. Inshallah. All right. I have a very busy week this week. I have four assessments. I have assessments on Saturday, Sunday, Tuesday, and Wednesday. I will still try to make some time in Monday. And if you're on Monday, that is obviously a question.
I can do Monday, yes.
Monday would be mm, Monday is 19th December, right? Monday is
Yes.
19th December. 19th December around 12. I remain free at Mondays after the classes, but uh, like teachers have missed some classes, so they take extra classes. Sometimes there are some workshops or various works and so on, so on. Okay, so for the time being, Monday, 19th, 12/4 p.m., right? Okay.
Okay.
Okay, Allah Hafiz for today. Thank you
Allah
and
for
good
today.
morning.
Thank you. Good morning and good night.
Yeah.